Thank you for that very kind introduction. Yeah, definitely note there will be zero testing in the next 50 minutes. The only testing we do is in production, right? And it's not really a DevOps talk. It's a talk about analytics. It's a talk about a database. It's a talk about what's going on in software architecture and in the world that would even motivate a new category of database. If you're in my talk yesterday, that was kind of a walk through the kinds of trade-offs that we make in trying to build a particular kind of database. There's a tiny little bit of overlap. You'll see that. It's towards the end. So we talk about indexes. So if you're there yesterday, you get that again. You're just going to know it real well. But the rest of the talk is really a very different thing. I remember, so I work at StarTree. I run the developer relations team at StarTree. StarTree makes a cloud service that's a fully managed version of Apache Pinot. And when I was looking around thinking about what I might do next, I was taking calls from folks who wanted to talk about developer relations and how do we do that. And that's usually a recruiting conversation. It's never just coffee. And it seemed like so many of them in the last 2-3 years were analytics startups. Like everybody is an analytics startup. I mean, everybody right now is going to be an AI startup, but man, there's a lot of that. And then this company StarTree came across my radar. I'm like, oh, an analytics startup. That's a great idea. I want to be the next Snowflake, and who doesn't? It's just that if there's 200 of them, for all values of you're not smart enough to pick the one that's going to be successful. So I was skeptical, but then there's a lot of other ideas going on here. This isn't just about how to make dashboards. It's about the way I look at it from the perspective that I kind of bring into this from spending a few years in the Kafka and event-driven architecture space. There is this event-driven revolution that is happening to us, and some of you may be helping it happen, but for a lot of us, it's like a wave that's sweeping over us. And like a lot of actual revolutions that take place, some existing or old institutions kind of become outdated or invalid or not useful anymore, but the new institutions that replace them are not necessarily there. Let me be a little more specific and a little less revolutionary sounding. It used to be that when we wrote programs, there was a database, and then we build an application around the database, and that was a good life. Like we knew how that worked. And it wasn't a bad thing until it was, and then we started using this kind of creepy name for it. We started calling it a monolith, like it's somehow scary or otherworldly or unchangeable or something. And I don't ever want to set up monoliths as some sort of foil that's just bad. It's a perfectly valid paradigm. And again, it was familiar. You send queries to the database and you get stuff out, you serialize it as JSON, you send it back to the browser and you get stuff and you put it in the database, and that's like kind of your life, right? Analytics were kind of a solved problem. I mean, an ever-evolving problem, but you knew what to do. You took data out of this transactional database and you put it somewhere else. In the old days, it was a data warehouse, and in only slightly less old days, it's a data lake, and there's an existing tool set and kind of just a bunch of stuff that's understood there. And we all know why this is now under threat as a paradigm, right? Monoliths famously are not great at managing complexity. We have only so much, as philosophers of mind say, so much noetic equipment. You're only so smart. You're human, and you can't fit too much program into your head at once. And so a very big application, you can't fit it into your head. It's hard to change. It's probably hard to test. It's maybe slow to deploy, blah, 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 right? So the idea is make software smaller, break up the monolith into microservices, and that starts to solve that. Now, of course, breaking software up into microservices introduces a lot of problems. Now you have all these services that need to talk, and that's a part of the event-driven revolution. Putting them on some kind of event substrate like Kafka has proved to be, I think, the most workable way to make microservices work. But there's another problem. Another motivator for this event-driven revolution, which is that batch doesn't really cut it anymore for a lot of things. Now, for your business analytics, I'm going to show you a chart in a little bit and kind of position some things on that chart. Your CFO wants dashboards. Batch might work for that, some kind of relatively quick batch process. That's fine. How up to date does that really need to be? But now that we carry, all of us, pocket computers that are connected by radio to a global network, you actually, maybe you haven't thought about this, but you do expect the pocket computer to wiggle when something in your commercial life or social life or something like that changes. You expect notifications. Oh, that's a fraudulent credit card transaction, or I just bought an SD card in Paris, which is unlike me. And my phone is like, hey, what's that? That was strange. Is that you? Are you okay? We actually expect those real-time notifications to happen. And batch processes are famously bad at that. So that decade-long kind of secular shift in the way we expect to interact with the services that mediate our life put batch under some pressure. Okay, so we had monoliths, we had the push toward real time, and now we've got this new stack, right? There's something like Kafka on the bottom, doesn't have to be Kafka, but it usually is, and then on the top, you write your program. And this is the thing that the differentiated code is actually, it takes care of the people who use the software that you're doing. It adds some value to their life. And in between, right now, dragons, right? Again, it's not like there were no options with monoliths. You had, choice of framework and language and any number of things, but we got to kind of a period of stability where we knew what those choices were, and now we don't. Yeah, now that you've got a bunch of little programs, this is sort of the default architectural approach, a bunch of little programs that are sending events to one another, it can be hard to know what has happened. And there's this race in kind of this exploration happening in the Dragon territory in there to figure out ways of querying the log. Logs aren't queryable structures. Kafka is not queryable. It ought not to be queryable. It makes no pretense at that. It's just giving you the next event and storing things if you want to read them back. So, at StarTree, we have a podcast, and I don't think any of these episodes have come out yet, but I've been recording this series about how to query streams, just talking to different people, different technologies that are out there, like Kafka streams. Kafka has an approach where I can turn a stream into a table and do like key value lookups in it. I can dump stuff into database of my choice. There's Flink. There's stuff that's not Kafka, that's outside that ecosystem, where I can kind of start to do queryable things. I can just make my own. There's this land grabby exploration going on in that space in there that suggests that we don't have the answers, that the stack has been shaken up and we need to do something. The fundamental thing is that, the fundamental impulse here is that we do need to know what has happened. And we often want to do that in a way that we want to get insight into what has happened. All right, it's one thing to say, I need to do a point or a primary key lookup on this entity. It's another thing to say, what is the trend in this thing in the last 2 minutes? This is a pressing need, and the revolution isn't quite there yet because we don't know what those things are. We don't know what the right tool in that space is. Pinot is one that presents itself as an element inside that stack now that would like sit on top of Kafka. You could think of it as a way to make Kafka queryable. There's a little bit more to it than that, but if anybody asks you what Pinot is and you want to be a little bit cute, you could say it's queryable Kafka. And that, if they don't really have a good mental model of it, that's a terrible explanation, but you can be like all mysterious, and then maybe they'll ask you and you'll be like, well, okay, I'll explain. Tools for you. All right. That's the context, and that's why I think this matters, and why I think this is actually a thing that, to stay ahead of the game, you do need to know what's going on in the real-time analytics space. But let's break down analytics, and obviously we do these things with quadrants. What would I even be if I didn't give you a quadrant at this point? So let's make, on the vertical axis, we'll have real-time versus batch. Now, that's not entirely binary. I think there are kind of, there are, technologies do tend to fall on one side of that or the other, but in the boundary, things always get a little fuzzy. So we'll have that real-time versus batch, and then internal-facing analytics or external-facing analytics. So historically, all analytics are internal facing. If you go back to the beginning of commercial computing, late 1940s, first mainframes being made and sold are being sold to governments and very large businesses that have enough money to buy them because they're super expensive things, and they're operating at a scale where that kind of number crunching that those early mainframes could do was useful. They were analytics machines. They were batch analytics machines. That's the beginning of commercial computing. They were so expensive that you had to be a very high status decision maker to get access to that kind of capital and that kind of reporting, right? So analytics began as an internal thing. In the modern era of the data warehouse, which is, I mean, it's like 35 years old now, but that sort of analytics as we sort of understand it now, again, for kind of people with nice offices and nice clothes. And that's kind of pushing to this external facing analytics, which I'll explain. All right, so yeah, down here, batch, internal facing, reports. We don't really print reports so much anymore. We have browser tabs with dashboards in them. That's the same thing. It's just the browser version, and it's a little more live. So those are internal and batch things. Internal and real time, you have specialized observability solutions. There are the famous $65 million bill. Did anybody read about that? It was Datadog. I think it was like Q1 a year ago, and it happened, and they didn't say anything. But Q1 this year, they're like, oh yeah, by the way, hard to cover this up, but a year ago we charged somebody $65 million, one customer. Now they fixed that, so you see that in the results, that kind of thing. Anyway, observability monitoring tools are real-time analytics tools that face internally. Very specialized solution. Over here is what I'm calling user-facing analytics. So that's taking the same data that you might put in a dashboard or would have in the olden days printed on a laser printer or something, and you are making it into a feature of an application. It is not a faster dashboard. If you have a database that goes 1,000 times faster than BigQuery, you don't make 1,000 times more dashboards. It's not useful to do that. And you don't just have a dashboard that refreshes 1,000 times faster. Zero people care. So Pinot's purpose in life isn't faster dashboards. It's taking the same kind of data that you'd be exposing to internal decision makers, packaging it as features that face the user. I will give examples, but that is why this thing exists, or why it came to exist, and the kind of use case that it makes the most sense in. And you could still make reporting a feature, right? Like I could have a thing where download a report of this. So there can be external facing batch things where, it goes and builds it and emails me, or it's just, last month's activity or whatever. That's totally fair, but you could do that with existing technology. And what technologies do these things? So batch, internal, legacy data warehouse, legacy Hadoop, and I kind of use Hadoop as a category. It's like Hadoop and its children and its grandchildren, Spark, and any of the other things that are doing distributed computation and data in that way. I tend to lump the query federation tools like Trino into this category. Snowflake, commercially, BigQuery, all those kinds of things are very good and deserve to have a place in everyone's stack, but they are not. They are oriented around the internal-facing dashboard and relatively batchy processes. And to the extent that, say, like Snowflake is growing the ability to ingest from Kafka, that's cool, but we'll have to look at how that actually works and whether we would consider it a real-time technology. Up here, yeah, Datadog, $65 million a quarter, whether you want it or not. No, I'm sorry, that was one time, and everybody's giving them a hard time for it. And like I said a minute ago, if you had download a report as a feature in your application, you'd just do that same thing with as you would for all the internal-facing reporting technologies. You just put it in cache. Up here in the real-time external-facing stuff, you have things like Druid, ClickHouse, Rockset, Pinot. Those are primarily the technologies vying for prominence in that new category. This is a talk about Pinot, but those other three are I would say like direct competitors. You wouldn't ever deploy both of them in one system. You wouldn't choose them both. You could very, very easily use BigQuery in your system and use Pinot in your system and be a responsible person who has made good decisions. They're going to be in different parts of the application doing different things, but there's nothing bad about both of those being present. Who does this? Pinot was born at LinkedIn a few years after Kafka. So they decided event-driven architecture was the thing to do, and they built out, they built Kafka, according to legend. Jay Krebs rage-coded the first version of it over Christmas break, I think 2009 or 2010. And LinkedIn, I think, did pioneering work making that transition to services talking to each other over Kafka topics. A few years later, if you remember LinkedIn at that time, it wasn't real exciting, right? It was like if you changed jobs, you'd go there and update your job, and every once in a while you'd go add contacts. So it was sort of like contact database and resume. You wouldn't use it daily. It wasn't properly social media. They started adding interactive features like Who Viewed My Profile, which seemed creepy at first, but this was built as a real-time feature. So this wasn't Who Viewed My Profile an hour ago or yesterday, but those events are all flowing through Kafka topics, and they had to build a database to be able to serve that stuff in real time. The first version they built was on this, basically kind of a search tool, internal document search thing that they'd built, and it was super expensive to operate and not fast enough and disappointing. And so that team reluctantly, according to the stories I've heard, reluctantly built the first version of Pinot. Like, nobody wanted to write a database, which I think speaks to the maturity and health and good choices of that team. Who would want to build a database, right? Terrible idea. But they did, and they had to, because they needed something that could ingest real-time events, make that stuff queryable right away to support this feature. And now everything on LinkedIn is, there's Pinot queries happening all over the feed, and how many people liked this, and deciding whether a post makes it into your feed based on activity of other people. That's all analytics happening on data that's not quite seconds old. And 100,000 or more queries per second hitting a Pinot cluster, and under 100 millisecond latency on the typical queries being sent to the database. We'll come back to those characteristics, that freshness, concurrency, and latency. That really is what sets a so-called real-time analytics database apart from a traditional analytics database. You have different, in fact, I don't know if I come back to it later. Let's just talk about it right now. Once I'm exposing analytics as a feature in an application, most of us do not operate at LinkedIn scale, but the number of users of an application, especially if it's consumer-facing, is a lot larger than the number of internal decision makers. So people actually refreshing a dashboard inside the company right now, 1 per second would be a lot. People using a feature in an application, like refreshing a LinkedIn feed, or meal delivery is another early Pinot use case, searching for a burger joint near me right now and wanting to know the delivery time, which is a real-time aggregation of all the deliveries that have happened in the last 5 or 10 minutes. There will be potentially many people being an analyst in that sense, right? So you're serving lots of queries. If it's in the user interface, 100 milliseconds is kind of a long time. I tap on something and I've already got network latency and other things in a pipeline and other database queries and who knows what, and I want that result to come back. I want it to feel alive, so 100 milliseconds is kind of on the high end for that. And if it's a real-time system, I want the data to be seconds old. And seconds might be the time it takes to propagate through whatever my Kafka pipelines are to get up to here. So I don't want the database batching things up and all that. So latency, concurrency, freshness, those are the things that the requirements I would recommend you think about, or the non-functional requirements I would recommend you use to separate a real-time analytics database from a Snowflake, a Spark, a BigQuery, or whatever. Yeah, like I said, meal delivery, another huge use case. There are all of the major global meal delivery services happen to be all Pinot users. Like it's not like ClickHouse does one of them, and Pinot, it's just, Pinot, for some reason, Pinot won in that use case. It's a great thing. We're feeding the hungry, or at least the hungry and impatient. The hungry with lots of disposable income. You know, frankly, not that hungry. You could have done this some other way, but we're glad you got to stay in tonight. Okay, time is money. Fair enough. Yes, it is. So it's a legitimate choice that people can make. There's really nothing to say about this. It's tables. It's a very uninteresting topic, and this is likewise uninteresting. This is SQL, and that's it. Right now, as of Pinot 0.13, joins, production-capable joins are limited. You can have a special kind of table that is like fairly small reference data that gets duplicated all over all the nodes. We'll look at architecture in a minute, but all over all the servers in the cluster. A pre-production feature that is being tested right now, and I think some ambitious people are using it in production, is arbitrary joins between large tables. So the subset of SQL that is implemented is growing to be close to coextensive with ANSI SQL. It'll probably be another release or two, so maybe this fall, fact-to-fact joins will be considered production ready. So, and those are unlikely to be your 75 millisecond queries, right? If you have something that is very performance sensitive that would require a fact-to-fact join, that might be a situation where you do the enriching in your stream processing system before you ingest, which is very typical, by the way, of Pinot living in a broader system. You want a topic, you connect the topic to Pinot, and those messages map onto rows in your table. And so you want to make sure all the elements, all the columns that you want in your table are there. That may require some stream processing before you do that ingest. And so for the super latency sensitive queries, you'd want to do the enriching on the streaming side. But we'll soon have that option. So yeah, it's SQL. Nobody cares. It's just not interesting. You care if you're reading the docs, and that's it. All right. To talk about Pinot architecture, I kind of like to take a slightly narrative-focused or narrative-based approach here by telling the story of a message being ingested. So let's start with an event. This is a click on a website, it looks like, and that's a perfectly honorable kind of data to ingest. Happens to be in JSON format. That means nothing. It just looks nice on the screen. So we're going to ingest that into a table. We'll have lots and lots of these events happening. And by the way, I am describing right now the batch ingest case. And that is typically the less interesting case, but we have to start here and we'll layer streaming on top of it. And it'll make much more sense if we start here. This works though. There's a command line tool. You say, hey, my data is this big thing off in this S3 bucket. Here's the credentials. Go ingest it, and that will happen. And yeah, I mean, we have batch data lying around. Nothing wrong with that. So here's how we handle it. We're going to ingest that into a table, and that tool is going to, as it's reading that data in, decide at some point, okay, that's enough. I've ingested enough records. I'm going to create a thing called a segment. And a segment is, for purposes of this approximation, you can think of it as a file. Obviously, it's going to be a few files, but it's just like this file that's got that group of rows that you've ingested. And it'll decide, either based on size or number of rows, that it's had enough. And it's going to create a segment. So as it continues to ingest, it creates more segments. And a table is made up of these segments. Easy enough. What's a segment look like? Well, here we get to see a little bit about some decisions that Pinot has made. So if you're in the talk yesterday, where we were doing this choose your own adventure thing, how if you wanted to be an analytics database, you have the choice, am I going to store my data as rows or columns? Am I going to take everything in a row together and serialize that to storage? Or am I going to do something different? Well, if you're an analytics database, you want to store columns together. You're going to outperform a database that stores rows together. Storing a row implies that that entity is the thing that you want. And if you're a transactional database, it probably is. I want to seek to here and read this block, seek. Seek still means something. It's, it's faster to get this chunk of stuff out of storage, and you want to be able to get that whole chunk at once. If, material or dehydrating entities is the thing you do. That's not what you do in an analytics database. What you do in an analytics database is you scan the values of a column. That's your limiting thing. Your performance limiting thing is scanning measurements. So what we'll do is we'll group up all the column values together. So the columns are stored. So there's, say there's 200,000 rows in this segment. All 200,000 values of IP are in that chunk, are written there. User ID. Oh, there's an index. Okay, we'll write the index for user ID. Remote user time. There's a time range index. We'll write that. So the columns are stored and the indexes are stored. The columns are stored all together. The indexes are stored with them. That's what it means to be a column-oriented database. And again, the reason for that is just imagining, I'm looking at this data, imagining an aggregation. Maybe I want to know like the average number of bytes for queries that came back with a 501 or something like that. I don't know why that would be meaningful, but I'm not the SRE, now am I? To do that, there's some range of columns, maybe all the columns in the segment, maybe only some of them, but I'm going to be scanning across that bytes, that collection of bytes, and so I want them to be all in one place, not skipping all over the place because the rows are everywhere. All right. So I've got a bunch of these segments, and they've got that internal structure like that. Just keep going and just give them numbers, and I'm going to store those segments on a component called the server. And naming things is hard. So here's evidence of that. That's actually what it's called. This is, in Pinot, this is called the server. There are other components that are also, my understanding, they may run on things that you might call servers, but the server in Pinot is where the work of query processing gets done. It's where the data is stored and where queries are actually sent so that the computation of that query, whatever filtering, sorting, things like that, grouping, actual execution of the aggregation function, all that stuff is done close to the data. So I've got a high bandwidth connection to the SSD, and I've got tightly coupled compute and storage. You don't, sometimes the question comes up, where's the magic, right? Like why doesn't every database do aggregations in 75 milliseconds across petabytes of data? I mean, that'd be 75 milliseconds would be a filtered set of the petabytes, right? But like, was everybody just being lazy and the folks who wrote Pinot decided, no, we'll just be smart and real good at this? No, there's all kinds of different trade-offs being made. The coupling of compute and storage is a very timely, relevant one in the last 10 or 15 years. And there's been a tendency to decouple compute and storage for very good reasons. And when you're building dashboards, the kind of performance penalty that decoupled compute and storage imposes on you, you don't feel it. It's fine because it's fast enough. And then you get all the benefits of decoupled storage. Pinot says, well, I can't do that. I'm trying to serve queries to the user interface, so I have to keep them coupled tightly. And now we kind of pay the cost for that. It's going to be more expensive to have all that storage on, a machine that runs Pinot that's not optimized for, being a cloud blob store or something like that. Anyway, there you go. So servers, tight coupling, replication works the way you'd expect it to. Nice thing about segments is in the typical case, they are immutable. So replicating them is easy. Just copy them around. And I'm going to skip a slide for our convenience. What else do we have? We got servers. In open source Pinot, there's a thing called deep storage where I can take old segments and write them into a cloud blob store. And I can't query from that cloud blob store. It's just a place to put them. And if I need to go get one, I'll bring that whole thing back onto a server. So it would be like tiered storage if you were bad at tiered storage. It's not a bad feature. It's just it's not what you would think of as, I have older data and I'll put it out there. Now, warning, commercial product statement being made for your convenience. StarTree makes a hosted version of Pinot, and StarTree Cloud has a tiered storage feature that they talk about. It is a more clever version of this. So if you see that, it's not Pinot deep storage. It's actually kind of cool. We're going to be releasing a Lightboard video about how it works because it's kind of nifty. But you get tiered storage at a performance penalty, but like not a severe performance penalty. Anyway, servers, deep storage, broker. The brokers are what clients talk to. So you throw a query at a broker, and the broker has access to metadata that will help it decide what segments are required to satisfy that query, which means it can say, what servers do I need to scatter that query to, so those servers can do the actual computation. And then the smaller result set that they return, they'll do that work locally, and then over the network, return the results to the broker, which will gather them, combine them, and send them back to the client. And brokers are, of course, also clusterable. There's another machine called the controller. That is an Apache Helix controller. Helix is the cluster management framework that Pinot uses, which in turn uses Zookeeper to persist its own metadata. So there you go. That's Pinot. And you've got that stuff being ingested probably all the time. That's what a cluster looks like. There's a lot of pieces there. It's hard to be a distributed database. And so this is how it does it. Everything here is Apache, yes.
Why is who uses Zookeeper? Why is
Kafka used to use Zookeeper. I mean, still, currently, yeah. Everybody wants to write their own implementation of Raft, right? If you're a distributed systems engineer, it's what you want. And hopefully you get to do that. And so the Kafka team did that. Also, I mean, Zookeeper has just been such a workhorse and it's just been there, but everybody who operates it hates it. And so that was never a pleasant part of the Kafka operational story. And I'm sure 3 years from now I'll be talking about, hey, we're removing Zookeeper from Pinot, big surprise. Zookeeper is absolutely the default, strongly consistent, low latency state store for systems like this. And the folks who built it, I mean, it was built at LinkedIn, which I think has had a lot of affinity for the ASF, and certainly at the time that would be the place that you go. This was early CNCF days. That's kind of the other big collection of open source things. I'm thinking of them as enemies, but maybe they are. In the back there. Yeah, so the question was, when we're doing search, do we look at specific segments? Yeah. And I don't think, by the way, the asking questions live is great. It's way better than at the end, so you folks are doing it right. I don't want to pick on the word search, so don't let me do that. I want to elaborate on that word for a minute, and then answer the actual question that you meant. So when I say search, and the precision I want to give to that word is, that's like what Elasticsearch does, where I've got all this stuff, its own distributed storage and indexing system, and I ask for some results, and I get results back, and essential to that result set is some kind of ranking. Like, this thing really matched, and this thing kind of matched, and this thing didn't match as well. And so when there's an idea of ranked results, that's when I say search, I mean that, and Pinot doesn't do that. So you definitely need something like Elastic to do that. But when I have stuff and I want to look for it, just, what you meant, I can certainly just do a select star and no predicates, which means all of the segments. Go scan all of the values for that column for all the segments, aggregate the results. That's totally fine. But if I am filtering, if I have predicates in my where clause, then the broker is going to be able to know from those predicates what segments are those filtered values in. It doesn't know what the values are, but it knows where they are. And so it will scatter to just the servers, the limited servers that have them. So there's two things you can do, right? If you're Pinot, you can scan faster. Okay, that's, always work on optimizing that, and scan less. There's really nothing else. There's no other magic. You can scan faster or scan less. Work smarter, work harder, work smarter. I don't know which one's which. And so that looking for the right segments is scanning less.
I guess what I'm trying to drive to is that when you're doing a query, if you're looking for segments, you know what you're looking for. But if you do a star, you're touching every single thing, right?
Yes.
So how does that compare to something like maybe like a KSQL?
Like KSQL?
Yeah, like if I don't know what I'm looking for, I'm touching every single segments. Is the performance impact going to be same as doing a search on like a index-based database? Is there any advantage over the other, like maybe monolithic style database? Like what advantage am I getting from Pinot if I don't know what I'm looking for?
Yeah, if you're always doing a select star, then that kind of implies, and that's the projection. If there are never predicates, right? It's always an aggregation and there are no predicates. That tells me that you should be doing something like Kafka Streams or Materialize or Delta Stream or KSQL or one of the streaming SQLs or streaming APIs, because you want literally every event involved in the aggregation. There are other motivations that would push you away from Pinot and into one of those, like if you're processing events, you're doing your analysis, whatever that is, your compute, and you want the results to go back into a topic again, kind of that round trip, then it's not Pinot. Pinot is a terminal place for data where we're going to do things in a specialized way, optimized for, again, the user-facing use case. So you're onto that. If there's never a predicate, you don't need any of this. You need a stream processor. If you want predicates and you want indexes, which we're going to get to in a minute, you will die over there in the streaming SQLs or the Kafka streams. Life gets hard quickly. So you have to know what you're doing, what you're trying to do, and that implies the right tool. And again, it's probably going to be both in a practical system, right? Just like you're a perfectly sensible person with BigQuery and Pinot, Kafka streams and Pinot, they are probably going to coexist. I think if you have a follow-up, wait, do you? So there's less microphone running. Yeah, you first, and then.
Sorry, didn't mean to dominate. So this means that with Pinot, I have to know my data, and I already know what I'm trying to derive from it. It's not meant to say that I have maybe 100 terabytes of data coming in. I'm going to see what can I get. Right?
Yeah.
I know what I want already.
Yeah, I mean, to some degree, the following is a somewhat vacuous statement, but you have to know what you're trying to do to pick the tool. And I don't mean that. I'm not making light of the question with that, but absolutely, you do have to understand that, because there are certain kinds of things that, like Pinot or something like it, is kind of the only way you can get it done. And then there are other kind of things where it'll be not quite fit right, or just a bunch of wasted effort. Yes, question here.
Hi. So how broker is deciding like which server data has to go? Like is just some algorithm like partitioning key or kind of thing?
Not exactly a partitioning key, but the segment limits are stored in Zookeeper, and the brokers have a cached copy of that. I'm just going to leave that explanation at that level right there. So the brokers know for these values of these columns, these are the segments.
Okay. And when we are doing, like you said, like a select a star, so does it, it's a very time consuming thing, like we are scanning all the servers?
If it's a big table and there are no predicates and you want all the columns, yes, that will take a long time. So typically you're aggregating on a measurement, and there are a few dimensions that are interesting that you're using to filter the values of that measurement that you're interested in. That is typical. The aggregate of all things for all time is generally not what you want. And if that is what you want, then that's a stream processor. Usually there are conditions, like I want a hamburger, but I'm in the West Loop, and I want $2 signs of price range, and I want a hamburger. That's a constraint. So I just gave you 3 dimensions right there. And now go filter and aggregate and give me the result. So there's a question next to you, I think.
Hi. Just a follow-up question on that. Is there a fine-tuning on the broker's metadata store? I mean, can I refresh them as I wish, or I can fine-tune those configurations?
Yes, there's plenty of tuning, and that also kind of gets to specific index types. There's tuning to do, but I'm going to give it a yes. And I said before, I'm not your SRE. That's because I'm not your ops guy. So I don't know the stuff. I don't know the tuning stuff well. But yes, of course it exists. Now, I said that we were going to talk about batch and then streaming ingestion, and so I am. When we do batch ingestion, we call that table an offline table. Naming things is hard. Can you query an offline table? Yes. Will it give you results in a performant way? Absolutely. Is that offline table in a robust sense online? It is. Okay, so yeah, you write the segments, and if I'm doing real-time ingestion, now I've got a Kafka topic. Let's just say it could be Pulsar, could be Kinesis, whatever, but source of events, and I've bolted it onto Pinot, and I consume into an in-memory structure called the consuming segment. And that in-memory structure is queryable just like all of the static segments that are on disk. So whatever I have not yet written to a segment, which is what I do when the consuming segment fills up, I can query. So, and Pinot is a native Kafka consumer. There's no Kafka connect, there's no intermediary, there's a topic, and there you go. As soon as it consumes a message, as soon as the message has been consumed by the Kafka consumer, it's in the consuming segment and queryable. So there's no extra latency. You just get to read the stuff. Let's talk about indexes. We've got about 5 minutes left, and we got to cover indexes. Here we are. I think that was literally my next slide. I had to go find it rather than just advance to it, but no, here's what we're going to do. The forward index, just to kind of get indexes warmed up. This is really basic. Now, this is like asking, okay, I've got a row, and I've got some identifier for the row. Where's that row? But this is a column database, so that row is not in one place. So what a forward index does is actually tell me where is this column. So I want the IP of a particular row in my clicks. Well, that's where this value of that row is. And again, rows are scattered all over the place. We identify them internally with a thing called doc ID. So in this trivial view of a table, I'm only showing you one column. I've got location. That's doc ID and location that you're seeing on the left there. I map doc ID onto location. So if I know the doc ID, I can go get that. And for a low cardinality field like this, it'll actually be dictionary encoded. So you can store very little data. Inverted index is the opposite, and I will skip the slides and take you straight to the animation. It looks like this. So if I have the value now, the term, I can learn what documents that appears in. So yeah, again, great for filtering if I've got low cardinality fields. That's a cool thing. Let's go to text index. You could think of this like its own little embedded Lucene on an index or on a text column if I got a big text blob. So I can do phrases, I can do Boolean combinations of things, prefixes, regular expressions. There's a geospatial index. Uber, for their meal delivery service, Uber Eats was an early adopter and remains a stellar open source contributor. They contribute all kinds of code to Pinot, including their H3 library, which divides the world up into hexagons like a big, giant tabletop RPG. And this is worth its own talk. There's a lot to say there. There's a JSON index. You might have a column that is a text blob, but it's JSON, and you might want to do like JSON-aware queries, index into arrays, have complex nested JSON objects, all that stuff kind of makes it into the index. So you can do performant queries with JSON predicates, all kinds of timestamp support. Pinot's not a time series database yet. You can't create a table that doesn't have a timestamp column. So, Pinot's not a timestamp or a time series database. That's a dubious claim. It's not. If you look at the time series databases and complex query types and complex index types, they're built for different things. There's different sets. Careful now. If you didn't hear that on the video, there was just a super loud noise from back there that I think scared about half of us. Anyway, you get to define a grain. Say you have some millisecond accurate timestamp, but I'm always interested on what happened on a particular day. I want this to tell me what are the doc IDs for July 8th, 2022, or something like that. Well, then I can, given that grain, group up all of those doc IDs that had timestamps that are in that day. So I get this efficient way to filter for particular days or hours or minutes or seconds or whatever my grain is. Last index I'll cover is the StarTree index, not to be confused with the name of my employer. We just thought it was a cool thing and we took it. The company was originally called Cortex Data when it was founded. So I'm going to go with StarTree was an upgrade. This is like building a pivot table and persisting it to disk. So if you've never made a pivot table, then that's probably reflective of good choices that you've made in your life. But I have, and what you're doing is you're computing an aggregate based on the combination of 2 or 3 or 4 fields in the database. Okay, so suppose I've got ad impression data. There's not too much ad tech in the Pinot world, but there's some. So country, browser, locale. And if I'm always filtering by country and maybe then browser and maybe then also locale, then the StarTree index actually builds a tree that's log n traversable with pre-computed aggregates in it. So I never have to go seek into any column data and do that compute. I've just got the number in the index. So the performance numbers always, they look like hacks. You know, it's just, you get crazy performance. That brings us to time and wrapping up. This whole thing that's happening to us of transitioning to event-driven architecture, of responding as the people who build systems, responding to this default change in the expectations of human beings that your phone wiggles when something happens. I mean, that's kind of, it's not like 20 years ago where you went to a computer to get online. You are all the time. And as a result, more and more of our commercial and social lives are mediated through devices that do things right away. And now we're responding with the systems we build to be able to do things in real time. We're responding to unmanageable monolith complexity by breaking perfectly good programs up into distributed systems. All of the disruption that has attended that change, which I think is the first substantive change in software architecture since the late 1980s, and ask me afterward if you think that sounds ridiculous, the work of redefining the stack in the middle isn't done yet. I think tools like Pinot are likely to be an important part of that, and to understand how to navigate the new event-driven world. I think this is kind of technology that we should have in our back pocket. You want to know more? And you all want a new Slack workspace to join. I know I do. Take a picture of that, join that. I'm usually in there. Thanks for being here.